ahead and read it for us.
The circuit diagram below shows a battery with an EMF of 24 volts and internal resistance of 0.8 ohms. The potential difference across resistor 1 is 15 volts and the current through the ammeter is 3 amperes. When switch S is closed, the resistance of R2 is 3 times that of R1.
Okay, and that's all. Okay, thank you so much, Josie. So here they say the circuit diagram below shows a battery with an EMF of 24 volts and an internal resistance of 0.8 ohms. The potential difference across the resistor R1 is given to us as 15 volts, and the current through the ammeter A, it's 3 amperes. When the switch is closed, the resistance of R2 is 3 times that of R1. Okay, that's fine. Okay, so let's analyze the statement. They said to us the resistance of resistor R2 is 3 times the resistance of the resistor R1. Okay, that's fine. It's understood that statement. Now, what they said to us, they gave us the potential difference of the 15, not really, of the R1 resistor. They said it's 15 volts. And since R1 and R2 are connected in parallel, then we understand that the resistance of R2 is also 15 volts. Okay. They also gave us an EMF of 24 volts. That's nice. Okay. And next they say what? They give us the ammeter. In other words, the ammeter reading, the current that passes through the resistor R1. That's fine. Okay. Then they say, explain what is the meaning of an EMF of 24 volts. So this means the battery supplies 24 joules of energy to each 1 coulomb of charge that passes through it. So that is the meaning of an EMF of 24 volts. Okay. Then they say calculate the resistance
Can you
of
please
R2.
repeat your answer? I didn't please. Can you please repeat your answer? I didn't hear what you said, sir.
Yes, it means the battery provides 24 joules of energy to each 1 coulomb of charge. It's what we said in the last lesson, whereby I showed you a sketch whereby the charges are at this point, at that point, at that point. So we were interpreting the potential difference in terms of the energy per 1 coulomb. Or you can say it's the battery supplies a maximum of 24 joules of energy to each 1 coulomb of charge that passes through it. That's the meaning of the EMF of 24 volts. Yeah, so that's the meaning of 24 volts. Okay. And next they say calculate the resistance of the resistor R2. Now that you know what is the meaning of the EMF, that's fine. Now, how do we calculate the resistance of R2? Well, in order for us to find that resistance, we have to use the relationship between the resistor R1 and the resistor R2. What is that relationship? They said to us R2 is 3 times R1. So it means if we can know what is R1, then it's very easy for us to find R2. Because think of it, what is the information that is given to us about R2? Well, it's only the potential difference. We only know that the potential difference of R2 is 15 volts, and there's nothing else that is given. But if you look at the resistor R1, we know the current that passes through it. We also know the potential difference, so we can find the resistor R1. Okay, so let's go to the resistor R1 and find its resistance. So we say, okay, fine. According to Ohm's law, R1 equals V over I. You can label this as 1 as well, because you are specific that you're talking about resistor R1. Then you say we are looking for this resistance. Yes. The potential difference is given to us as 15. And the current is given to us as 3 amperes, right? So this means that the resistance of the resistor R1 will just be 5 ohms, all right? Okay. So now that we know resistor R1, then we can say, but they told us that R2 is 3 times R1. So which means you just say 3 times 5, and you simply get your 15 ohms like that. So this is the magnitude or the resistance of the resistor R2. And you should. So if we go on to the next one, they say to us, calculate the current that is passing through the bulb. Okay. If we look at the situation once again, we know that a bulb is a form of a resistor, right? Even though we don't know what is the resistance of the bulb, they didn't tell us what is the resistance of the bulb, but we can see that this bulb is actually connected in series, which means the current that passes through this bulb is just going to be the main current, the total current. So that's what they're actually asking us to do here. Now the question is, how can we calculate the total current if we don't know what is the total resistance? That is a very, very good question. We don't know the resistance of the bulb. So how then can we find the total current? Well, it's very easy. If we can find the current that passes through these two resistors connected in parallel, then that current actually passes through the light bulb. Do you see that? Even though we don't know how much is the resistance of the bulb, but we can focus on those two resistors in parallel and find a single resistor that represents both of those. Then we can calculate the current that passes through both of those. Right? Or we can do it in the easiest way possible. What is that? Calculate the current that passes through R2, because we already know the current that passes through R1, right? And then we add those two currents up. And then we get the current, which is the total current. Do you see that? I think that's the easiest one. So let's do that one. Yeah, because we know that resistors connected in parallel, they divide the current of the circuit. So if we know the current that goes to each branch, then we add those currents up we get the total current. So now we calculate the current that passes through the resistor R2, and we call it I2. Or you can say I2 ohms. It's still fine as well. We can manipulate Ohm's law like this. Let's state the original principle, because that's what I'm busy teaching you. So now we can say R2 equals V2 divided by I2. The resistance of the resistor is 15 ohms. The potential difference is just going to be what? Well, it's 15 volts as well, yes. And then the current is the one we are looking for. So it means our I2 will just be 1 ampere. So now that we know the current that passes through the 2 ohm resistor, then we can say the total current is equal to the current that passes through the 2 ohm, not the 2 ohm, the resistor R2, I mean. And then we add these to the resistor R1, which we know it's 3 amperes. So yes, the total current will just be 4 ohms like that. Or you could have done it in the first way that I told you. So what is the first way that I told you? I said to you, we could have calculated a single resistor that represents those in parallel, right? Yeah, which is your R1 as well as your R2. So you can find that total resistance of those two. So let's go ahead and do that. So you'd simply say, okay, fine, your RP is equal to R1 times R2 divided by R1 plus R2. So this is what you would say. And your R1, we know that it's, what is it anyway? It's the one that we calculated. I think we got it to be 5. Yeah, we did. And our R2 was 15, yes. And we divide this by R1 plus R2, like that. So now we have 5 times 15 divided by 5 plus 15. And we simply get 3.75 ohms. Okay. Now we know the potential difference of, the total resistance of those in parallel. So now we can find the current that passes through a total, like that resistor that represents both of those in parallel. So you can simply say, okay, fine. Stating our Ohm's law, we say R equals V over I. And then you'd say the resistance of the resistor is this. The potential difference of those in parallel is 15, and we are looking for the current. Then we said, if you want to make the denominator to become the subject, you just take what was the subject and make it the denominator, and you take your denominator and make it the subject. And if you press this into your calculator, voila, you simply get 4 amperes, and your happiness is complete. So the next one says, calculate the resistance of the bulb. All right. Now, if we look at this bulb, well, the bulb, we can see that it's connected in series. That's nice. And so in order for us to find its resistance, we actually need to know its potential difference, number one, and we also need to know the current that passes through the bulb. We already know the current that passes through the bulb. We said it's going to be 4 ohms. In fact, amperes, sorry. Now we just need to know the potential difference, okay? That's fine. We are given the EMF of the battery, which is 24 volts. But we know that it's not the whole of 24 volts, which is available to the resistors in the external circuit. We know that the internal resistor is going to come to this EMF and take a certain proportion from it, which we call V internal. But then one thing we know here is that we know the potential difference of those connected in parallel. So if we can find the potential difference of the internal resistor, we can now say the EMF minus the potential difference of the internal resistor minus the potential difference of those in parallel, then we can get the potential difference across the bulb. Yeah, so let's do exactly that. So what I'm saying is as follow. I'm saying the first thing we need to do is to find the potential difference of the internal resistor. And this one, we know that we are allowed to go ahead and say it's equal to IR, okay? But for everything else, we begin with the original Ohm's law. The total current or the current that passes through the internal resistor is 4 ohms. And the resistance of this resistor is given to us as 0.8 ohms. Then if you say 4 times 0.8, you'd simply get 3.2 ohms. This is what you have. All right. Now, what is wrong with me? It's supposed to be volts because we are finding the potential difference. Sorry about that. Now we know that in order for us to find the potential difference of the resistor in series, we are simply going to say the EMF minus the potential difference of the internal resistor minus the potential difference of the resistors connected in parallel. So we have 24 minus 3.2 minus 15 volts. And if you press this into your nice calculator, you find that the potential difference of the bulb, which is a resistor connected in series, will be 5.8 volts. So now we know the potential difference of the bulb. We also know the current that passes through the bulb. So we can now easily use Ohm's law and say R equals V over I. And then you say we are looking for the resistance. We now know the potential difference. We also know the current. And if we divide those two together, we find that the resistance will be 1.45 ohms. So this is what we will say, and our happiness will be super complete. So this one says, the bulb is now removed and replaced with a conducting wire. In other words, one of the resistors is now removed and it's replaced with a conducting wire. And we know that conducting wires, we ignore their resistance. So we can assume that the resistance is removed completely. We are now left with those two resistors in parallel. Okay. So what? Then they say, how will this change affect the reading on the ammeter A? In other words, or what is the ammeter A anyway? The ammeter A is the current that passes through the resistor R1. Okay. I think it makes sense for us to make a little bit of a sketch, even if it's a rough one. Yeah. So this is our ammeter A, and this is our resistor R1, and this is what we have here. And of course, this is our R2, and this is our right. This is what we are having, and the circuit is still like that. Awesome. So we want to know, will the current that flows through this resistor R1, is it going to increase, decrease, or remain the same? Okay, that's fine. Now, in order for you to answer this, you always have to go to your Ohm's law and check what is going to happen. Now, if we remove one of the resistors connected in series, then what is going to happen to the total resistance? The total resistance of the circuit is going to decrease, and the current will have to increase. Because we removed the resistor that was in series, so definitely the total resistance will decrease. But if we had removed a resistor in parallel, the total resistance was going to decrease. Please note the difference, because we know that resistors in parallel, they decrease the total resistance of the circuit. The more resistors in parallel you have, the smaller the total resistance. The less resistors you have in parallel, the smaller. No, man, what am I saying? Yeah, the less resistance you have in parallel, then the higher the total resistance, right? But for this case, we know that the total resistance will decrease. So the answer is the reading on the ammeter increases. Why does it increase? Well, it's because the total resistance decreases. So that's the first thing you say. After telling us that the total resistance decreases, remember what I told you. Every time when you explain, try by all means to refer us to a principle. In this case, Ohm's law. You can either write it as a formula, or you can write it in terms of the proportionality constants, okay? So this is what you will say. You'll say, since the resistance is inversely proportional to the current, but every time when you state a proportionality, you must tell us what is kept constant, because you're comparing two things. So the third one has to be constant. When the potential difference is kept constant, yeah, so you say, since the resistance is inversely proportional to the current, when the potential difference is constant, then what is going to happen? Well, the total current will increase. Very important. All right? Over and out, and you get your nitrogen. So a 100 watt. They give you the power, but in watt. That's fine. So a 100-watt light bulb is replaced by a 21-watt low energy equivalent bulb. Okay. The cost of 1 kilowatt hour of electricity is 91 cents. The homeowner has an average of 10 light bulbs burning for 4 hours a day. Okay. How much will the homeowner save in 30 days if he replaced these 100-watt bulbs with the 21-watt low energy bulbs? Okay, so what do we need to do here? We actually need to calculate the cost, the total cost that the homeowner spends, right? But here we need to calculate two costs. We need to calculate the cost for the 10 100-watt light bulbs. And we also need to calculate the cost for the 10 21 watts light bulbs. Then in order to find how much he will save, then we'll say the bigger cost minus the smaller cost. Then the difference of those, it's what the owner will be saving. Okay. And they didn't tell us if the answer must be in cents or in rands, but I think it makes perfect sense for us to convert the final answer to rands. Yeah. We don't use cents anyway in everyday life, but we can do our calculations in cents and then convert the final answer in what? In rands. Now the formula is still going to be the same. So we say the cost, but we have to specify, right? So we can say this one is the cost of 100-watt light bulbs. And we know that the cost is actually given by the power multiplied by the time multiplied by the tariff. But then this one would be the cost of one appliance, right? This is the formula that you know all along. It's for a kettle, for instance. It's for a stove, a single appliance. But in this case, they're saying we are dealing with 10 bulbs. So you have to multiply by 10 bulbs because you don't have one bulb, you have 10 of them. It doesn't change the formula, but then you're now considering that you have 10 of them. Okay. Now, the power is given to us as 100 watts, and we know that it must be in kilowatts. So we simply take 100 and we divide it by 1,000. So we get 0.1 kilowatts. They said to us these light bulbs, they burn for an average of 4 hours a day, right? Of course. And then they said, well, the tariff is going to be 91 cents. Let's keep it as 91 for now. Or we can convert it to rands. 91, it's going to be a very big number, which is unnecessary. So we can just say, what is 91 cents anyway, if we convert it to rands? Oh, now this is the conversion. We need to be practical here. If you remember that 1 rand, no, we don't say 1 rand like that, right? 1 rand is actually composed of 100 cents. Do you agree with me on that? Because we know that 1 rand is actually made up of 10 cents. A 10 cent, I don't know what you call it in your village, but we used to call it shilling. Yeah, get shilling. And I think I do have a shilling in my savings there. So yeah. So if ungadi shilling say 10, you take 10 shillings and then you add them up. They give you 1 rand, right? So which means 1 rand is 100 shillings. I don't know what is a shilling in English, but that's what we used to call it when I was growing up. Now we want to convert 91 cents to rands. Then how do we do that? We say this one divided by that one multiplied by that one. So you simply go to your calculator and say 91 divided by 100. Then you simply get 0.91 like that. So this is your rands. You don't need to put the rand here, but you won't be penalized if you put it as well. So that's your tariff. And then you multiply this by the number of bulbs. Then you say 0.91 times 0.1 times the number of hours times 10. So you simply get 3.64 rands. Just to make sure that I did the right thing. Of course. So this is when you're using the cost of, or rather, when you're using 100-watt light bulbs. Then we come back again and calculate the cost when you're now using 21 watts. So once again, we are given watts, so we have to convert it to kilowatt. So it's 21 divided by 1,000, which is going to be 0.021. You multiply this by the time in hours. You multiply this by the cost of 1 unit of electricity, which is the tariff. And then you say, once again, we have 10 light bulbs. Then if you now press this into your calculator, you simply get 0 rands, 76 cents. Now you say, what is the difference between the two? That's how much the homeowner will save. So maybe here you can call it the saved amount. I don't know. You'll just say what it's going to be 3.64 minus 0.76. And if you find the difference between these two, then you find that the homeowner will save a significant amount of money. So yes, that's how much the homeowner will save. So they said in 30 days, we have to multiply this by 30 and multiply that one by 30 as well. So 3.64 times 30, it's going to give us, sorry about that, I completely overlooked it. It's going to be 109 rands, 20 cents. Your calculator will give you 0.2, but of course you're dealing with money, so you must make sure that it's in. You must add 2 decimal places, cents there. Then you come back to this 0.76. You multiply it by 30. Because what is this? What is this 3.64 and the 0.76? It's the cost in 1 day. It's 4 hours a day. But here we must consider that it's 4 hours a day for 30 days. Sorry, I overlooked that. Then this one will give you 22 rands 80 cents. And then you'll say, how much did he save? Well, it's actually 109.20 minus 22.80. And therefore, he has actually saved 86 rands, 40 cents in the period of 1 month. I'm really sorry about that. 30 days, terribly important. Otherwise, you die.